This is a video from section 10.2. The directions say to find the area enclosed by the given parametric curve and the x-axis. So here's the formula we need. Area is the integral from a to b of y dx. And what we're going to do is we're going to take this integral and transform this integral into an integral in terms of t. Okay? Now, let's take a look at example 1. Suppose we're given the following parametric equations: x equals t to the third plus 1 and y equals 2t minus t squared. So the book provides you a picture which I drew on the other page here. Suppose we're given this parametric curve. Now, the area we're trying to find is highlighted in blue. Okay? Now, again, the formula is the integral from a to b of y dx. Okay? Now, remember, y is 2t minus t squared. So notice I'm trying to transform this integral in terms of t. Now, dx, which we can figure out over here, is 3t squared dt. So I'm going to come over here and I'm going to replace dx with 3t squared dt. Now, I need to figure out my limits in terms of t. So notice this limit and this limit over here are in terms of x. To find my limits in terms of t, I'm going to set y equal to 0 and solve for t. Because remember, y is 2t minus t squared. So I'm going to set 2t minus t squared equal to 0. Factor out a t, and you get 2 minus t equals 0. So t is 0 or t is 2. So this a will correspond to t equals 0. B will correspond to t equal 2. So I'm going from 0 up to 2. Well, this is the integral from 0 to 2 of, that looks like 6t to the third minus 3t to the fourth dt. So let's go ahead and rewrite that over here. So this is the integral from 0 to 2 of, let's go back, 6t to the third minus 3t to the fourth. And we're going to integrate this with respect to t. So this will be 6t to the fourth divided by 4 minus 3t to the fifth divided by 5. And we're going to evaluate this from 0 to 2. Now, we're going to replace t with 2 to get 6 times 2 to the fourth divided by 4 minus 3 times 2 to the fifth divided by 5. And then I'm going to replace t with 0. But when you plug in 0, you're just going to get 0. So this is 6 times 2 to the fourth is 16 divided by 4 minus 3 times 2 to the fifth is 32 divided by 5. And so 4 goes into 16 4 times. 4 times 6 is 24. So this is 24 minus 96 over 5. And so the answer to example 1 is 24 fifths. Let's take a look at example 2. Suppose I'm given the parametric equations x equals sine t, y equals sine t times cosine t, and t is less than or equal to pi over 2 and greater than or equal to 0. So again, the book provides you what the parametric curve looks like. So here we have x and y, and what's nice about this problem is they already gave you the restrictions on t, so we don't have to figure that out. So the curve looks like this, something like this. So we're going to come over here, and I'm going to highlight the area in blue, what the region, the area of the region we're trying to find, which is right here. Again, remember that area is the integral from a to b of y dx. So here, we're going to go from 0 to pi over 2. Y is sine t times cosine t. dx, I can come over here, and that ends up being cosine t dt. So I'm going to replace dx with cosine t dt. So this is the integral from 0 to pi over 2 of sine t times cosine squared t dt. So we'll do this by use substitution. We're going to let u be cosine of t. du is negative sine t dt. So sine t dt is negative 1 du. Now, we're going to transform this integral in terms of u. That means we have to do everything in terms of u. So, when t is 0, u is 1. And notice I'm plugging in up here to solve for u. Okay? And when t is pi over 2, cosine of pi over 2 is 0. So u would be 0. And so I'm going to have negative 1 times the integral. And I'm going to go from 1 up to 0 of u squared du. But I'm going to switch those limits. And if I switch the limits, I can drop the negative 1. So I don't need that negative 1 anymore. Okay? So I'm going to take the integral from 0 to 1 of u squared du, which is 1/3 u cubed, evaluated from 0 up to 1. And so the answer to example 2 is 1/3. And that's going to conclude this video for section 10.2, where we did 2 examples of finding the area enclosed by the given parametric curve and the x-axis. Okay, thank you.